The cart on a track. Right now, it is practically horizontal. If I tilt it and I let it go, start traveling down the track faster and faster. This is the motion sensor. I will use it to measure how distance changes with time. Experiments might be dangerous. Experiments might be dangerous. Of course, we don't care about anything that happened after this time. I'm going to select this region and I'm going to try a linear fit. And it's not really a good fit, as you can see. So I'm going to try a better fit. And better, well, what's next after linear? Quadratic. Quadratic. Try fit. Oh, now the fitting is really, really good. What conclusion can I make? The motion equation for the coordinate as a function of time is not linear. It is not like this. No, it's quadratic now. In mathematics, we would write like at squared plus b times t plus c. And in this situation, actually, the software uses capital letters. That's the only difference. And this coefficient, capital A, is equal to about 0.122. If we use international system of units, it should be with meters and seconds. We don't know yet what. Now I can repeat a similar analysis here, but now it looks like linear. And for linear, well, now it's velocity here. So I know for this type of a motion, this should be equal to something linear like this. This coefficient should be equal to acceleration, and this coefficient should be equal to initial velocity. And if I read this graph, the slope is equal to about 0.4, and that's is meters per second. And interesting fact, if I take this coefficient and I multiply by 2, I get this coefficient. 0.2 times 2 equals 0.4. And I can do the same experiment 100 times, or maybe 1,000, or maybe 10,000 times, again and again and again and again. And this is what I will observe again and again and again and again. For all graphs, these coefficients are related like this. Well, I know this is the acceleration because this graph represents velocity as a function of time. So the only time that is important is this time when the cart was actually moving on the track. And for this situation, we can always use these equations. The equations on the left represent velocity equation. The equations on the right represent the motion equation. It's a quadratic function. The graph for position as a function of time is a parabola. Technically, now you know everything about motion with constant acceleration.